Yes, welcome back to a new video on trigonometric identities, the last topic of your trigonometry. Let us see the identities and questions, and with that, we'll conclude our chapter. Let us start our chapter. See, when you're talking about trigonometric identities, we need to revisit for the right angle triangle. Let us take a right angle triangle. A, vertex B, vertex C, angle 90. From this, what is the hypotenuse? This, because always opposite to 90, which we learned in the last video, correct? Now, if you see here, let us do everything with respect to angle A. Where is angle A? Here. So this BC will be what? Opposite. And this AB will be what? Adjacent. So opposite, adjacent, hypotenuse have been done. So now let us learn. Using Pythagoras theorem, what can we write? Base square plus perpendicular square is equal to hypotenuse square. What is base square plus perpendicular square? Nothing but AB square plus BC square is equal to AC square. Now, why I am giving you this particular Pythagoras theorem is because with this we are going to write all the three trigonometric identities, where I am going to explain you only the first, the second, third you are doing and you are learning on your own. Let us say I will divide whole Pythagoras theorem with AC square. Let us see what will happen when I divide AB square by AC square, correct? BC square by AC square, AC square by AC square. Now AB by AC heard somewhere. BC by AC heard somewhere, correct? So BC by AC is what? Opposite by hypotenuse. Let us write first. That is nothing but sine square A. You may ask, sir, why sine square A? Because this is opposite with respect to angle A. That's why sine square. First we wrote this. So this coming is sine square A plus AB square by AC square. What is AB square? Adjacent by hypotenuse is what? Cos square A is equal to AC square will cancel out each other, 1. So this is the first identity of trigonometry. Sine square A plus cos square A is equals to 1. From here we can write individually for sine square A and cos square A. How? Sending cos square A to other side becomes 1 minus cos square A. Let us check it out. Sine square A is equal to, already 1 is there. We sent cos square A, is going to become minus cos square A. The same way, if you do for cos square A, keeping it here, sending it to other end, nothing but by transposing or by balancing method, what are we going to get? Cos square A is equal to 1 minus sine square going to other side is minus sine square A. Now, if you see your trigonometric table which we learned in the last class, the angle A is defined for 0, 30, 45, 60, 90. Angle is defined for 0, 30, 45, 60, 90. So, condition is applicable. A is greater than or equal to 0 because our angles are between 0 to 90 only. It can be 0 or it can be greater than 0 and less than or equals to 90 everywhere. This trigonometric condition is applicable. Now the same way, if you solve using some pattern, you're going to get towards that pattern you are identifying and giving you the identity. The identity of second one, secant square A minus tan square A is equals to 1. From here I'll write for secant square A minus tan square A going to other end is going to become plus tan square A. So secant square A is equals to what? 1 plus tan square A. Is it very clear? Now, if I want to write for tan square A, I'll just send 1 to this end. So tan square A is equals to what? Tan square A is equal to secant square A minus 1. Now you may get a first doubt, sir, how secant square A minus tan square A? Using this, think what you should divide, where, then you are going to get. Same way, there's one more identity, but before that, conditions are very good. Condition, if you see tan table and secant table, tan 0 to 90, secant 0 to 90, they are not defined for 90 degree. So this angle A cannot be 90. You check your table in the last class which we learned. So A is greater than or equal to 0, less than 19, equal to case will not come because at 90 tan and secant are not defined. That's why these two are grouped with secant square A minus tan square A. The same way, cosecant square A minus cot square A is equals to 1. Now the same way, can you rewrite for cosecant square A, cot square A, what you are going to get? Why I am writing these from one other two? Because they are going to help you while solving the questions. Now the condition. If you see cosecant A from 0 to 90, you see cot from 0 to 90, they are not defined for 0 degree. So your angle A cannot be 0. Check your table. They are not defined for A equal to 0. So A cannot be equal, but it can be greater than 0. This is called A greater than 0. Less than or equals to 90 degree. Now, these are the trigonometric identities which are very useful in solving the questions on trigonometric identities. Let us start the very important question. Find or express all trigonometric ratios in terms of secant A, which you are solving. I am going to tell express all trigonometric ratios in terms of tan A. Express all trigonometric ratios in terms of tan A. So there are 6 trigonometric ratios. All the 6 should be expressed in terms of tan A. I'll start with the easy way. First, tan A is equals to tan A. So tan A is expressed as tan A only. Second one, cot A is equals to 1 by tan A. So any trigonometric ratio you should write in terms of tan only. That is the meaning of express all trigonometric ratios in terms of tan A. So tan A is tan A, cot A is 1 by tan A. Now I am seeing the identities. And here I am able to see secant square A minus tan square A is equal to 1. Secant square A is equal to what? 1 plus tan square A. Write this identity. The third one, secant square A is equal to 1 plus tan square A. Now my first doubt, is secant square a trigonometric ratio? Secant A is a trigonometric ratio. Sir, secant A, absolutely correct. So sending square to other end is going to become square root. So secant A is equals to under root 1 plus tan square A. When you know for secant A, cos A is done because secant and cos are reciprocal. So cos A is equals to what? Cos A is equals to 1 by reciprocal. Nothing but by 1 you write. Reciprocal is reverse. So it's under root 1 by 1 plus tan square A. So for cos A it's done. Now sir, how to write for cos square A? Send root to this end. Nothing but cos square A will be equal to 1 by 1 plus tan square A. Sir, why did we get this? Because here secant square A, if I want cos square A, I'll do reciprocal. So by 1 it will be reverse. That's why. Sir, now what are left? Tan is done. Cot is done. Secant is done. Cos is done. What are left, sir? Sine is left. Cosecant is left. So now how to do? It's very easy. Let's go for the first identity. Where you see for sine, sine square A is equal to 1 minus cos square A. What is sine square A is equal to 1 minus cos square A. Or we can also apply this. Which you want to apply, it is up to you. Which you want to apply, it is up to you. Now, which you want to apply, you tell me now. Which you want to apply, because anything you do, you are going to get the same. Let us do this. Okay, let us do this. Let's do for the sine square A. Sine square A is equal to 1 minus cos square A. 1 minus, what is cos square A? 1 by 1 plus tan square A. When you make the denominator same, what is going to happen? 1 plus tan square A will come here. So 1 plus tan square A, this is minus 1, by denominator will be 1 plus tan square A. So plus 1 minus 1 will cancel out each other. There will be 0. So sin square A is equal to what? Tan square A by 1 plus tan square A. But do you need tan sine square or you need sine? Sir, we need sine. When you need sine, we are going to get sin A is equal to whole under root tan square A by 1 plus tan square A. So now you did for sine square A. How to do for cos square A? Try it in the same pattern. So your cosecant square A. Because from secant we got cos. So from sine can't you get cosecant square A? After getting cosecant square A, can't you get cosecant A? Try it out. And sir, we understood the logic, we understood the concept. Now we want to learn one more question on our own. So instead of tan A, you do for secant A and sin A. You need to express all the trigonometric ratios in terms of secant A, all the trigonometric ratios in terms of sin A. Yes, let us see this question. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus secant theta into cosecant theta. Is very important for your NCRT and SCRT. And I'll tell you the easy trick. As soon as you see the question, don't fear. You're supposed to prove it. Proof take LHS. What is your proof take? LHS. What is your LHS? This. After taking this, express them in terms of sine and cos. So what is tan theta? Sine theta by cos theta by 1 minus what is cos theta? Cot theta. Cos theta by sine theta plus. How you can write as cot theta as what? Cos theta by sine theta by 1 minus sine theta by cos theta. If you see this, sin theta into 1, sin theta by sin theta. Cos theta into 1, cos theta. So cos theta minus sin theta by cos theta. Let us write that steps. Numerator is not changing in the denominator. We are solving in the first step. So sin theta by cos theta whole by sin theta into 1 is what? Sin theta. Sin theta minus cos theta by sin theta plus this numerator is as it is, cos theta by sin theta whole by cos theta into 1 is what? Cos theta. So cos theta minus sin theta whole by cos theta. Now if you see here, this a by b by c by d division, then we'll do reciprocal. Let us do that step. So the reciprocal step, what is going to happen? The numerator as it is, sin theta by cos theta. This division changes to reciprocal, so it becomes sin theta by sin theta minus cos theta plus this numerator is as it is, no change. So write cos theta by sin theta into, because this division changes to into, and they will change their places. So these two, c by d will become d by c. Cos theta by cos theta minus sin theta. Now sin theta into sin theta, sin square theta. Cos theta into cos theta, cos square theta. Before that, I want to tell you one more thing here. Sin theta minus cos theta minus sin theta. Can I make them same? Yes. How? Take out minus here. So these two will change their places and its sign is going to become minus. Let us tell again. Sin theta minus cos theta, I want to make them same. Take out minus common. it will become these two change their places and this sign will change to minus. Let us see what happens. This is sine square theta because sine theta into sine theta. Denominator cos theta of sine theta minus cos theta. This became minus because I took out minus here. These two will change their place and this becomes minus. What is cos theta into cos theta? Cos square theta by sine theta of sine theta minus cos theta. Now you may get it out, sir, why they changed. I told you again, I took out minus common, so they changed their places and that minus has been multiplied here. If you see here, sine theta minus cos theta, sine theta minus cos theta is common. When they are common and when you want to take the LCM, your LCM is gonna be sine theta into cos theta of sine theta minus cos theta. This is your LCM when you solve this. Now you know already the LCM concept. Here cos theta of sine theta minus cos theta. So cos theta, sine theta minus cos theta. What is the extra? Sine theta is extra. So that should be multiplied to numerator. So sine square theta into sine theta is going to become sine cube theta minus. Here I will check sine theta of sine theta minus cos theta. Sine theta of sine theta minus cos theta. What is extra in denominator? Cos theta. So this cos theta will multiply with this and going to become cos cube theta. Now this is a cube minus b cube. What is a cube minus b cube? What is a cube minus b cube? A cube minus b cube is equal to what? A minus b of a square plus ab plus b square. Let us apply it. So a cube minus b cube sine cube theta minus cos cube theta is what? Sine theta minus cos theta. Correct, right? Sine theta minus cos theta of a square sine square theta, b square cos square theta, ab sine theta into cos theta. So sine square theta plus sine theta into cos theta plus cos square theta whole by this denominator has no change in denominator. Sine theta into cos theta, sine theta minus cos theta. When I check, this and this are same, so they'll cancel out each other. And this sine square theta plus cos square theta, I heard some it's an identity 1. So sine square theta plus cos square theta is what? 1. So you write 1 plus sine theta cos theta. Sine theta cos theta whole by what is in the denominator now? Only sine theta by cos theta. Now when you separate it, nothing but 1 plus 3 by 2 can be written as 1 by 2 plus 3 by 2. Using this logic we'll apply it here. So it will be 1 by sine theta into cos theta plus sine theta into cos theta by sine theta into cos theta. These two will cancel each other and it's going to become 1. So 1 by sine theta is cosecant theta. 1 by cos theta is what? Secant theta. So cosecant theta into secant theta plus 1. Nothing but RHS. So this and that both are same. So LHS is equal to RHS. This we took LHS. LHS equal to what? RHS. That is what we need to prove. Hence you are supposed to justify it. Hence prove. Now I told you this is very important. 3 marks or 5 marks. Only one question, sir. No. I'm going to tell you 3 more questions which are going to come in your boards. Okay. Yes. Let us see your question number 2. Very important and very expected and very easy. Prove that cos A minus sin A plus 1 by cos A plus sin A minus 1 is equal to cosecant A plus cot A. This is literally very easy. As soon as you see the question and you take LHS. When you take the LHS, when I see RHS, one more hint is striking my mind. Cosecant A, cot A. Okay. How to make it cot A? Cos A by sin A. So I'll divide whole numerator, whole denominator with sin A. So my first step of my solution is done. Let us see what it is. So see here, whole numerator and denominator divide with what? Sin A. So cos A by sin A minus, see this, sin A by sin A plus 1 is there, 1 by sin A. Not only numerator, whole denominator also divide with sin A. So this is cos A by sin A plus sin A by sin A minus 1 by sin A. Sir, what is the advantage of this step? Now I will be getting one step closer to my answer. Cos A by sin A, cot A minus sin A by sin A, 1 by sin A, cosecant A plus cosecant A by. Sir, cos A by sin A just now we told, sir. We understood, sir. So cot A. Sir, sin A by sin A, we understood, sir. Yes, what it is? 1. Sir, 1 by sin A, we know it, sir. How many times should repeat? So it is cosecant A. Now I am going to rearrange my terms. What do you mean by rearrange? I'll just change 1 and cosecant A place. I'll just change 1 and cosecant A place along with this sign. What I'll get? Cot A plus cosecant A minus 1. This is cot A minus cosecant A, changing the place of 1 and this, minus cosecant A plus 1. Now the next trick that is striking my mind in this concept on the same way you're supposed to follow. Check this, cot A minus cosecant A. Now you tell me one thing, what is equivalent fraction? What you do in numerator, same thing in denominator, no problem. So I'll take this and I'll multiply numerator and denominator. Only I'll multiply cot A minus cosecant A. Why? You're going to understand in some time. Check it out. So cot A minus cosecant A by cot A minus cosecant A. From here, one thing should be in your mind. Only solve numerator. Only solve numerator. Now let us say, see, cot A plus cosecant A, cot A minus cosecant A. This will multiply whole. So A plus B, A minus B is what? A square minus B square. What it is? A square minus B square. So let us write cot square A, next minus cosecant square A. Now this minus 1 is also multiplying this whole. So what is minus 1 into cot A? Minus cot A. What is minus 1 into minus cosecant A? Plus cosecant A. Okay, now denominator as it is, no change, or we are not touching denominator, right? The denominator cot A minus cosecant A plus 1 of cot A minus cosecant A. Sir, what did you gain by this? This, I have some idea. Cosecant square A minus cot square A is equal to what? But this is reversed. Yes, when this is reversed, we are going to write in place of this as minus 1, not plus 1, because we know cosecant square A minus cot square A. But this is cot square A minus cosecant square A. So reverse it and write sign as minus 1. So minus 1. This whole is going to become minus 1 because it's reverse of our identity. So what is left after that? Minus cot A plus cosecant A. Only this without minus 1, this as it is. Again, same thing. Nothing we are doing to denominator as it is. Cot A minus cosecant A plus 1. Next, cot A minus cosecant A. Now, this I'll do one small correction. I'll take out minus common. When I take out minus common, this will become bracket and it's going to be plus. When I took out minus common, it is also going to become plus. When I take out minus common, this is going to become minus. Only one thing I did, I took out minus common. If you multiply, you'll get a previous step back. Now check this. Cot A minus cosecant A. Cot A minus cosecant A. Plus 1, plus 1. They will cancel out each other. Now here minus is left. So one table now. So minus 1 by cot A minus cosecant A. Now what do we need here? What do we need here? Cosecant A plus cot A. How we are going to get? Before that, let us multiply the sign. Multiply the sign. So this is 1 by. When I multiply the sign, this will become minus cot A. This will become plus cosecant A. Means they will change their places. That's what we did even there. Changing the place in previous question also. So this is cosecant A minus cot A. Because when you multiply these two will change their places and signs also change. Now I want that. How will I get that? Rationalize the denominator. What is rationalizing? What is area cosecant A minus cot A? Rationalizing means what? Cosecant A plus cot A. Write it. Cosecant A plus cot A by cosecant A plus cot A. Now when I see this, it's very easy here. Why? Because this is cosecant A plus cot A and your denominator is 1 y1. Sir, A minus B, A plus B is what? A square minus B square. Cosecant into cosecant, cosecant square A. Cot into cot, cot square A is what? 1. So this and your RHS both are same. What we are supposed to prove? This. The same thing we got. Therefore, LHS is equal to RHS. And what is the final step? Don't forget, henceforth, and this is very important series of your NCRT and SCRT. They are going to come to your boards. So as I promised, we completed question 1, question 2, very important for boards. Also question 3, question 4, question 5, which I am not going to solve. You people, my followers, my subscribers and my children are going to solve. And this I'll give you the hint. Rationalize. Where do you rationalize? I'll just give you one hint and so that you can do it from there. Under root 1 plus sin A by 1 minus sin A. Way to rationalize are inside the bracket. 1 minus sin A is what? 1 plus sin A. 1 plus sin A. From here, you can get the answer right hands proved. Now this also, sir, how to do? Take out sin theta common. 1 minus 2 sin square theta. Take out cos theta common. 2 cos square theta minus 1. So sin theta by cos theta 1 and these numerator and denominator will cancel. Why it will cancel? Solve it, you will understand and tell why and comment your solution in the comment section. Now this is also very important question, very easy question. Sin A plus cosecant A whole square. What is A plus B whole square? Apply. What is A plus B whole square? Apply. After getting, this is sin square A, cos square A, 1. Okay, but it's cosecant square A or cot square A? Yes, very easy then. Cosecant square A is equal to what? 1 plus cot square A, right? This will be secant square A is equal to what? 1 plus tan square A, right? Okay, after writing everything here 2, 2, 4, 5 plus 2, 7. So we got the answer. Sir, you're telling very easily, but how to solve? Do it and check it out. Use my hints and comments. So with this, the chapter of trigonometry has been completed. We wound it off in 2 videos. Your 8.1 and 8.2 in one and 8.3 is one. Whereas for SCRT, it's for 8.1, 8.2. The 8.3 is different for SCRT and this is 8.4 for SCRT. Have a good day and we're going to come with a new chapter, the next video, applications of trigonometry. Stay tuned, subscribe. Thank you. Have a good day.